Thank you for joining me for this video and hope you're all having a fantastic day so far. One thing this morning, every time you make a mistake, you correct yourself and move on to make newer mistakes. And that's the way you learn anything on this planet. And welcome back to this channel, and those who have been in this channel for a long time might know that I have created a playlist. In that playlist, I have uploaded so many topics briefly but clearly. So practice every day pretty much. And coming back to the beginning, the topic today is on tests of hypothesis large samples. So when you say it is a large sample, when the sample size is more than 30, we say it is a large sample. Clearly, in the test of hypothesis, there are four types. One is the test of significance for single mean, difference mean, single proportion, difference proportion. There are four topics, and here is the third topic, that is test of significance for single proportion. So I'm clearly going to explain all the five steps here. The first one is null hypothesis. H naught is equal to, we have to take the proportional values are equal, P equal to P naught. And next one, for alternate hypothesis, you can take any statement, either they are P not equal to P naught, or P greater than P naught, or P less than P naught. And the next third step here is test statistics. In that we have to apply the formula Z is equal to small p minus capital P by root over PQ by N. Each and every term I am going to explain with an example here. And the next one is level of significance. There are going to be three kinds of level of significance, that is 1%, 5% and 10%. And this is the rejection table. Please take a screenshot so that you'll be getting all the values here. So for 1%, if calculated value is greater than 2.58, we reject. And for 5%, if calculated value is greater than 1.96, we reject the null hypothesis. And for 10% level of significance, if moderate value is greater than 1.645, we reject the null hypothesis. And this is the rejection table. And here is a note, that note 1. If the calculated value is greater than 3, then clearly we have to reject the null hypothesis without the reference of the level of significance. And the next one, coming to the limits. Here the limits are P minus 3 times of root over PQ by N is the lower limit, and P plus 3 times of root over PQ by N is the upper limit. And next one, coming to the confidence intervals. So this is P minus Z alpha by 2 root over PQ by N, and P plus Z alpha by 2 root over PQ by N. Z alpha by 2 depends upon the level of the significance. So here are the values for the level of the significance, and this is for 5%, 1%, and this is for 2%. And I have taught you example 1, 2, 3 in my previous video, and in my today's video I am going to explain from the fourth question here, the fourth one here. So here a die was thrown 9,000 times. How many times here? 9,000 times. And of these, 3,220 yielded A, 3 or 4. Is this consistent with the hypothesis that the die was unbiased? So here, what is given here? 9,000 times. So here clearly N is given as 9,000 times. And small p, the proportion of success of getting 3 or 4 in 9,000 times is getting a 3 on die and 4 on die. So here the proportion here of getting a success, no, proportion is equal to, see here the proportion value here is x by n. So this is x by n. So x value is 3,220, by this one is 9,000. This is 0.3578. And capital P is the population proportion of success, that is getting 3 or 4 this time. So small p formula here is x by n. So this is nothing but 3,220 by 9,000 is small p, and capital P is getting 3 or 5. That is 2 by 3, this is 1 by 3, this is 0.3333. Now P value is equal to 0.3578 and capital P value is equal to 0.3333. And now getting Q is equal to, the here is the formula, that is 1 minus P, that is 1 minus 0.3333, which is equal to 0.667. So here we got all the values, that is small p, capital Q and capital P and capital Q. And now here coming to null hypothesis, the die is unbiased. Alternate hypothesis, that is P is not equal to 1 by 3 or the die is biased. Test hypothesis. Test statistics, we have a formula that Z is equal to small p minus capital P by root over PQ by N. What is small p here? Small p value is clearly 0.3578 minus capital P 0.3333 by root over PQ, that is 0.3333 into 0.6667 by N value is 9000, the value here is 4.94. The calculated value is 4.94 and the tabular value at 1% level of significance is 2.58 from the rejection table. So here the calculated value is greater than the tabular value and therefore the null hypothesis H naught is rejected at 1% level of significance. Therefore, we have to reject this one. We have to reject that the die is unbiased, should be rejected, and therefore we have to accept H1, that is the die is biased. Clear? So these are all the 5 steps I've explained. And this is question number 5. Example number 5. A random sample of 500 pineapples was taken from a large consignment of 65 were found to be bad. Find the percentage of the bad apples in the consignment. See here what all are given. N is equal to 500 is given and X value is equal to, see, X value is equal to 65 is given and small p value is equal to X by N. So which is equal to, this is a 65 by 500. This is a 65 by 500. This is 0.13. And the next one, Q value is equal to 1 minus P, that is 0.87. So when P and Q are given, so we need the percentage value. So we have to find the limits for this. The limit formula here is a small p plus or minus 3 times of PQ by N, and this is P value is equal to 0.13 plus or minus 3 times of root over PQ, 0.13 into 0.87 by 500. So this value is nothing but 0.045. So if you subtract, this will be the answer. If you make an addition, this will be the answer. So we need the percentage so that if you divide, so we'll be getting a percentage. Therefore, the percentage of the bad pineapples in the consignment lies between, if you divide by 100, so this is 8.5. If you divide by 100, this is a 17.5 and this is the percentage. And next one, coming to the 6th problem. A random sample of 125 cool drinkers, 68 said that they prefer thumbs up to Pepsi. Test the null hypothesis P is equal to 0.5 against the alternate hypothesis, that is P greater than 0.5. And see, what is the data given? A sample of 125 cool drinkers. So among 125 cool drinkers, X is equal to 65. Small p value is equal to X by N, that is 68 by, this is 68 by 125. This is 0.544. And clearly, the number of persons who drink thumbs up is half and Pepsi is half. P is equal to 0.5 and 0.5. And next, coming to the step, null hypothesis, P is equal to 0.5. Alternate hypothesis, P greater than 0.5. Level of significance, if it's not mentioned, take 5% level of significance, that is alpha is equal to 0.05. Test statistics, here is the formula, that is Z is equal to, if single mean is given, small p minus capital P by root over PQ by N. What is small p here? 0.544 minus, what is capital P? 0.5 by root over PQ, 0.5 into 0.5 by N. What is N here? That is 125. After using your calci, the value here is 0.9839. So here at 5% level of significance, Z alpha by 2 value is 1.645. Clearly, the calculated value is less than the tabular value and therefore we accept the null hypothesis at 5% level of significance. And next, coming to the 7th question here, the experience had shown that 20% of the manufactured products is of top quality. So here 20%, the population here, capital P is given as 20%. In one day's production of 400 articles, only 50 are of top quality. So here X is equal to 50 and next one, N is equal to 400. Test the hypothesis at 0.05 level of significance. So this is most important. Please observe repeatedly as a question. And here N is equal to 400, X is equal to 50, small p is equal to X by N, that is 50 by 400. This is 0.125. Small p value we got as 0.125. And capital P value is equal to 20%, that is 20 by 100. This is 0.2. Q value is equal to 1 minus P, that is 1 minus 0.2, which is equal to 0.8. So all the values are ready and level of significance is 5%. Test statistics. The formula Z is equal to small p minus capital P by root over PQ by N. So what is small p here? 0.125 minus p 0.2 by root over 0.2 into 0.8 by 400. The value here is minus 3.75. So if you take modulus and observe with the tabular value 5% level of significance, it is 1.96. So clearly this value is greater than 1.96, and therefore we have to reject this one as it is greater than 3, or else the calculated value is greater than 1.96. Therefore we reject the null hypothesis, and therefore p is equal to 20% is not correct. And next, coming to the eighth question, is social worker believer that a fewer than 25% of the couple in a certain area have ever used any form of the birth control. A random sample of 120 couples was contacted. 20 of them said that they have used. Test the belief of the social workers at 0.05 level. So here a social worker believes that 25%. So here talking about the population, capital P is equal to 25%. And here n is equal to 120 couples were contacted. So here n is equal to 120. Out of them, 20 of them said they have used. So x is equal to 20. Small p is equal to x by n. 20 by 120. This is 1 by 6. So small p is equal to 1 by 6 and capital P is equal to 25%, and p is equal to 25 by 100, which is equal to 0.25, and capital Q will be 1 minus p, and capital Q is equal to 1 minus 0.25. Capital Q is equal to 0.75. So here is the small p value. Small p value is 1 by 6, capital P and capital Q are given. See here, small p 1 by 6, capital P 0.25, capital Q is equal to 0.75. As usual, null hypothesis P is equal to, that is 0.25, null alternate hypothesis P less than 0.25, level of significance alpha 5%, test of statistics, that is for single proportion. Z is equal to small p minus capital P by root over PQ by N. What is small p? This is 1 by 6 minus what is capital P? 0.25 by root over PQ. 0.25 into 0.75 by N value is equal to 120. The value here is minus 2.107. So this is the calculated value, and this is the tabular value at 5% level of significance for p less than 0.05. This is 2.33. So clearly calculated value is less than the tabular value, and therefore we accept the null hypothesis H naught, and that is the claim or the belief of the social workers is true, and we have to accept the null hypothesis, therefore it is accepted. And next one, coming to the ninth problem, a manufacturer claims that only 4% of his product are defective. So here 4%, capital P, the population is given as 4%. A random sample of 500 were taken among 100. See here, n is equal to 500 and x is equal to 100 here. Test the hypothesis at 0.05 level of significance. So here as usual, small p is equal to 100 by 500, which is equal to 0.2, and capital P is equal to 4%, that is 4 by 100. Capital P is equal to 0.04, capital Q is equal to 1 minus 0.04, which is equal to 0.96. And here coming to null hypothesis, P is equal to 0.04. Alternate hypothesis P greater than 0.04. Level of significance 5%. First test statistics, Z is equal to small p minus capital P by PQ by root n. So what is small p here? Small p is equal to 0.2 minus capital P 0.04 by 0.04 into 0.96 by n value here is 500. 500. The value here is minus 18.28. Clearly, it's 5% level of significance. It is 1.645. Here, this calculated value is greater than the tabular value Z alpha by 2, and therefore we reject the null hypothesis at H naught. And the 10th question here is, in a sample of 500, see here, in a sample of 500 from the village in the Rajasthan, 28 are found to be wheat eaters and the rest are rice eaters. Can you assume that both the articles are equally popular? Here n value is equal to 500. Small p is equal to, so this is x and this is, so x is equal to 280 and n value is equal to 500, and small p is equal to x by n. This is 200, so this is 280 by this is 500. The value here is 0 point, so small p value is equal to 0.56. And capital P, the number of wheat eaters are half, and the number of rice eaters are half. So these three are the values required, that is the small p, capital P and capital Q. And therefore, for a null hypothesis, as usual, null hypothesis, we say that both the rice and the wheat eaters are equally popular in Rajasthan. Alternate hypothesis, p not equal to half. Level of significance at 0.01 level of significance. And see here, at 0.01%. And the next question here, the next is test statistics. What is the test statistics here? The formula here is p is equal to small p minus capital P by root over pq by n. So here small p is 0.56 and capital P is equal to rice eaters half and the wheat eaters half, and n value is equal to among 500 they have calculated. So if you substitute each and every value, the value here is 2.7272, and at 1% level of significance it is 2.58. If you compare, so this is 2.58, this is z alpha by 2 value is equal to. So if you compare both, mod z value is greater than z alpha by 2. So if the calculated value is greater than the tabular value, we reject the null hypothesis, and therefore there is a conclusion that both the rice and the wheat eaters are not equally popular in Rajasthan at 1% level of significance. Thank you for watching, and thank you for staying very patiently till the end, as these are very important. And if you follow one problem after the other problem, the next problem you can guess what is capital P, what is small p, what is x, what is n, and how to get a q from p, and what is the definition, what are the 5 steps I have taken, what is level of significance, what is test statistics, null hypothesis, when to reject, when to accept, and everything will be crystal clear if you follow these series. And in my upcoming video I am going to post one more video related to the single proportion, and I'm going to shift to the difference proportions. Please make note that every formula is very important, and these are repeatedly asked questions, and this topic is damn easy if you follow the playlist one after the other. Thank you so much for watching. If you really like, you know what to do, please raise your thumb, pass it on to your friends, and subscribe to this channel.